All right, we'll go to the next topic. The next topic is all about what operation? Delete operation. Okay, so that is what we are going to do it now. Okay, so we'll see one after the other. So when you see this one here, delete in the head, delete at any value can be deleted, delete in the head, delete in the last, and delete at any position. That is what we are going to do it. So now what I'm going to do is, let me show you the diagram so that you will understand very clearly. Delete this one, go back to this one. So this is all about your delete operation. So I need to delete the node at any position, so that is what you will be doing. So here first one, it is going to be insert in the delete in the front, delete in the last, delete at any position. These are the three operations we are going to do it. Delete in the front, so which is this node will be deleted, this node will be deleted which is in the last, and this node is going to be deleted which is in the any position, are the things that we will be doing it one after the other. Now let us understand how this is going to work. So copy this entire thing. I'm going to put it here. Okay, so initially this will be here and this connection will be established here. Okay, all right. So this is how generally a linked list will look like. So I'm going to delete this particular node. So insert delete in the front. Okay, so let me write the code for that. Okay, void delete in front. Inside the bracket, I'm going to give all these things. Okay, so here no new node is not necessary, as we are not creating or we are not inserting any node. So here we are going to just delete it already, which is being done. So now run this code and we'll see how this code has the nodes. See, we have 1, 2, 5, 3, and 4 are the nodes we have. So we are going to delete this one and we are going to execute the code, right? So for that only I'm going to write it. So for that, what I'm going to do, if the head is equal to null, we cannot perform any deletion, as it is linked list is empty, because I've already told if the head is always pointed to the first node of the linked list. If first node itself is not present inside the linked list, then there is no node inside the linked list. So what I'm going to do is, if head is equal to null, if head will be equal to null, okay, where system dot out dot println list is empty. Yeah, so linked list is empty. So if head is equal to null, so which means what I have said is, if this node, this particular index position, the head next head data where you have the address of the first node, if it is going to be null, this node is going to be not present. If this node is not present, the other node will also be not present. So I can say when head is equal to null, okay, so when head is equal to null, where is that diagram? Okay, when head is equal to null, so this diagram, when head is equal to null, head, we are saying empty linked list is going to be there. So when head is not equal to null, we can perform delete operation. So now how we are going to perform delete operation in this one, we are going to discuss it. So if head is not equal to null, we need to check this condition. So what I am going to do is, I need to connect my head to the second node, as this node is going to be deleted. This connection what I have established here will be connected here, the second node. So now what I am going to do is, I am going to get the address of the first node next part. What is this first node next part? First node is what? Head, right? 100 is what? Head, right? So now 100 is what? Head. The node that I'm going to delete is going to be head. Head next part is going to be 200. Head next part is going to be 200. If I store that here, where inside the head, automatically this connection what I've established will be connected to the second node of the linked list, right? Second node of the linked list. By that I can say this node is not deleted, but it is still connected with the linked list. So new node, if I say automatically this will connect it to this one. So you need not to worry about this one, because first node, if I say this is going to be connected with the linked list, always it goes to the 2. So 1 will never be considered in the program. So what I'm going to do is, what I did, node, first node was what? Head, no, which is 100. That first node next to part, I'm going to store it inside the head. Okay, first node next to part, I'm going to store it inside head. So which mean what I have done is, head was equal to 100 in the beginning, correct? Head was 100. So head next is what? 200, right? So we'll write 200. Head next is going to be 200. Where is this 200? Head next. So instead of writing 200, I'm going to write head dot next. Is that understood? This is what I have done. In the place of 200, where I'm storing this 200 and getting stored inside head. So that 200 is there in the head. That is what we are going to do it now. So we'll see the code and we'll understand how that execution works. In the else part, what I'm going to do, I'm going to write a statement, head is equal to head dot next. That's it. So by this I can say the first node can be deleted from the existing linked list. Now as we already know, 1 is the first node of the linked list, so this will be deleted now. Now listen here. So list dot delete in the front, call this function and run it. It will not, oh my god, bracket somewhere I made a mistake. This is an extra bracket that I have given. Okay, so delete it. Now see, 1 is being removed. So I'll show you the difference between those two before deleting it and after deleting it. Okay, so before deleting it, okay, if you run the code, before deleting it I have 1, after deleting it I don't have 1. Okay, so next line I didn't give a, okay, here I'll put next line, system dot out dot print eln semicolon, run it and check it. See, in the first one, before deleting I have 1, after deleting I don't have 1. See here, before deleting I am printing it, and then I am deleting it and I'm going to the next line and I'm printing the value after deleting it. This is how delete operation will be done in the front. Okay, so we will remove this one. Okay, so now what I'm going to do is, I'm going to delete the last node. 4, I need to delete it. So in order to delete 4, okay, so go to this one, delete this one, you come back here, delete the last node. So copy this, put it here and zoom it. Now what I'm going to do is delete the last node. No, I need to delete this particular node. Node delete is there, no, this node has to be deleted. If I need to delete that node, then what you need to do is the first node you made it as temporary node, and you keep on iterating to the last but before node, and you need to make it as null here. This is what ultimately we are going to do. So how this is going to be performed, I'll do it. Wait. Okay, so now what I have done is, initially I made first node as a temporary node. First node is a temporary node. So let us create the next operation, delete in last. Okay, this is an operation that I'm going to call. Since I have removed the previous one, one will be exist, one will be there. The last node alone will be deleted. Okay, so now what I have done, ls.delete last. So I need to write the code for that. We'll start one after the other. Yeah, we will go delete operation. Okay, so now void delete last inside the bracket. What I'm going to do is I am going to iterate. Okay, so what I can say is if the head is equal to null, it is going to be anyway, it is going to be empty linked list, right? It is going to be empty linked list, else whatever that I've said in the last program, it is the same thing. Now what we need to do is we need to delete the last node. For that we need to make first node as a temporary node. This node is a temporary node. For that what I am going to do is node temp will be equal to head. Node temp will be equal to head. This is the first thing. This is what I have done. So you need to iterate this temp node till the last but before node. Till this node you need to iterate. Only then when you make this one as null, then automatically this connection will get deleted. So that is what we are going to do it. So now what I am going to do is I am going to iterate it. How I'm going to iterate? By using while loop, because last position we are going no, but last but before position you need to go. So what I'll be doing, while temp dot next not equal to null. Let me explain you. Okay, don't worry, this piece of code I'll be explaining you. If this condition is going to be true, I'm going to say temp is equal to temp dot next. Temp is equal to temp dot next. Okay, so how this is going to work, I'll show you in this diagram. Okay, so first let me draw the linked list. Okay, now let me have some 4 nodes. So this node I have marked as temp node, right? So temp dot next is what? This address, which is 100, 200, 300 and 400, right? So here it is going to be null, here it is going to be 400, here it is going to be 300, here it is going to be 200, right? So now listen very carefully. Now let me type temp is equal temp dot next dot next. Temp dot next dot next. What is temp dot next? Which is going to be 200. Am I right? So that is what I have mentioned here, 200. That 200 dot next is what? Nothing but 300, right? Right, this 300 I'm going to check it. So which mean I am there in this particular position, I am going to check here. So which is I am there in one position, I am going to check next node next part. That is what next node next part I'm going to check it. That is what the difference. Then if the condition is not going to be equal to null, then I'll be moving. So where I'll be moving, this position I'm going to do. So temp, I'll be moving this particular position. So that is what in the diagram I keep on moving all these things here, right? I'll be moving here. Now here not equal to null, yes, not equal to null, because I have made it is equal to null, because that is because 400 should be there. Okay, so it is not equal to null. From here, this is my temp node, no? So temp next dot next is going to be 400. 400 dot next is what? Here it is going to be null. So from here, if you check it, this part is going to be null. Okay, so 1 minute. I'll remove this one. I'll get this address. I'll put it here so that you're not confused. Okay, so temp dot next not equal temp dot next temp dot next is 400. 400 dot next what? Not equal to null. So it is not equal to null or equal to null? It is equal to null. So the condition gets failed here. Okay, so once the condition it gets failed here, so it will not move to the next step, as we have written the code temp is equal to temp next. So now what you need to do is temp dot next, this part, if I make it as null, okay, if I make it as null, ultimately this node will be deleted, because if I mark it as null, this will be deleted, right? So that is what we will be doing it here. So temp dot next equal to null. Okay, so now let me run the code and I'll show you. See, the last node alone getting deleted. 4 is getting deleted from the existing linked list. Is that clear? Okay, so delete at any position is the next thing that we are going to do it. Delete at any position. So okay, all right, so delete at any position, we will be doing it now. Okay, so get this piece of code and delete this one and put it here. Okay, all right, so this is what the next thing. So any position you keep on iterating, and once you reaches the position that before, so temp dot next is going to be 300, that will be stored and it will be connected here. This is what ultimately we are going to do it. That is what I am going to perform here. Just listen. Delete any. Okay, delete any, I am going to give it. Now get to this piece of code. This part alone is not the same, so delete in the at any position. Okay, if it is going to be null, then you cannot able to delete any node. No, so head is equal to null, you cannot able to delete any node. That is because your linked list is empty. So now moving to the next one, what we need to understand is just one thing: iterating n times. So first we are going to make temp node. Okay, first we'll declare temp node. Temp is equal to head. Okay, done. Okay, so which mean first node I have made this node as a temporary node. That node we need to iterate n times. So what you need to do is n times you need to iterate. So for I will be equal to 1, for I will be equal to 1, I less than position minus 1, I plus plus. So you are going to iterate n times based on n minus 1 time based on that. Then temp will be equal to temp dot next. So I'll be iterating each and every position. Okay, so I keep on iterating to the every position. I would have been reached to this particular position. Now the actual program comes. Now in between these two nodes, one node is there. This is what the node that I'm going to delete. Okay, for example, we will be deleting the node which is in the 5th position. Consider 1, 2, 5, 3 and 4 is there. 5 has to be deleted. So what I am going to do is the position, it has to be 3, right? The position, it has to be 3. So let me give any position which I need to delete it. 3 comma 3. 3 is the position that I'm going to delete. So what I'll be doing, I need to give the position. Int position, I'm going to write it, and anyway in the condition position minus 1 I have given, then temp is equal to temp dot next. I keep on iterating to the next position. Now what you need to do is, this is temp. Temp dot next is what? 400. Temp dot next is what? 400. 400 is what? This one, right? So temp dot next is what? 300. I'm sorry, 300. No, so let me delete this. I'll get this address, I'll put it here. Okay, so this is getting connected here. So remove this connection and put it here. Okay, so this is what the linked list looking like. I need to delete this particular node. Temp dot next is what? 400. Am I right? So 400 has to be stored here. Only then this node will be connected here. So temp dot next is going to be 300. 300 dot next. 300 dot next is going to be 400. 400 I'm going to store it inside the temp dot next part. So which mean temp dot next, which is nothing but what? 400. Am I right? This is what I have done. So now what you need to understand is just one thing. This 400 has to be stored in temp dot next part, right? That is why temp then it will connect to the last node. So what I'll be doing, so I'll be doing temp dot next, which is nothing but 300. I am going to give 400, right? So here 400 I'm going to give. Okay, so which mean what happened, automatically this connection will be established here. This connection would have been established. Is that clear? The connection would have been established, and you will be able to store what? So already 400, what I told, temp dot next dot next. This is what I'm going to do. So this particular statement I'm going to write there. What I'm going to write, temp dot next will be equal to temp dot next dot next. That's all. Okay, so now what I'm going to do, let me run the code. I'll show you how it is going to work. So I didn't declare this int I. Okay, see, when you see the node 5 is getting deleted. Is that understood? So this is all about delete at any position. So we have discussed now with this video, delete in the front, delete at any position, delete in the last, or the three major operation we have discussed today. So next upcoming videos we will discuss where is that? Okay, so this is there. Insertion is completed, deletion is completed, traversal is completed. Now searching and sorting has to be completed. So next video we will discuss that as well.